Hello. Today we're going to be looking at lessons 7.7 and 7.8, which is scale drawings and scale models. And the main thing to understand is scale drawings are two-dimensional renderings of an actual object, and scale models are three-dimensional renderings of those. So it's really just a representation of an object drawn on paper or modeled with a three-dimensional object, but on a smaller or larger scale depending on the scale that was used. So what you'll see in the table up above, which is the same table from the original note sheet, is some examples of scales that you'll see. So you might see a scale listed just as something like 1 to 20, which basically means that the units between the two are the same. So anytime we're doing a scale drawing or model, we're always going to take the drawing or model over the actual measurement. So that's something that we'll just use in general. So drawing or model measure will always be over the actual measure, and that's how the scale is given to us. So if the scale is 1 to 20, that's basically just telling us that whatever the unit is, it's the same unit on the drawing as it is in actual space, but the actual object is 20 times larger. The next scale we see is another type where we have two different units, and what it tells us is that for every 1 centimeter on the drawing, there's 1 meter of actual space on the object. And then another common one that you'll see that contractors often use is a 1/4 inch scale. And so you might even see it listed just as a 1/4 inch scale, but what it means is that every 1/4 inch on the drawing is equivalent to 1 foot of space. The reason that this is so common is a lot of grid paper is made with 1/4 inch blocks, so it's very easy to just shade or highlight a single block to indicate that that's representative of a foot. So when we look at example 1, it says the length of an object on a scale drawing is 4 centimeters, and its actual length is 12 meters. So the scale is 1 centimeter to blank meters. So to figure this one out, you're really just simplifying. We're taking, again, the drawing measure, which in this case is 4 centimeters, over the actual measure, which is 12 meters. And then we're going to simplify it because we can certainly see that the scale is 1 centimeter to a certain number of meters. So to get from 4 centimeters to 1 centimeter, I see that I just need to divide by 4. So I will do that same thing in the denominator, and I will get 3 meters. So what that tells me is the scale for this specific drawing is 1 centimeter to 3 meters. The next one, letter B, says the length of an object on a scale drawing is 2.5 inches. The scale is 1 inch to 8 feet. What is the actual length of the object? So there's a couple ways that you could think of this, but using a proportion is probably the easiest. So I'm going to start by listing my scale, 1 inch over 8 feet. And that's going to be equivalent to the drawing measure over the actual measure. In this case, I'm given the drawing measure, which is 2.5, and I'm missing the actual measure. So it's 2.5 inches up top. So I know that my actual measurement, x, will be in terms of feet. So again, there's a couple different ways that you could do this. You could simply cross multiply like we've done in our proportions lessons, or you could find a number that was multiplied to get you to the other ratio. So in this case, if I see that 1 was multiplied by 2.5 to get to the drawing measure, then I could also do that down in the denominator. And when I multiply 8 by 2.5, I end up with an answer of 20. So x would be equal to 20 feet. And that's the actual measurement of this object. Okay, now let's take a look at another one. This is something that you can probably relate to in example 2 using a microscope. And if you haven't done so in science yet this year, well, actually, I know that you did. So you've seen microscopes. So what we're told here is that Mr. Behringer's using a 1,000 to 1 view. So remember, that means that the drawing measure is 1,000 times the actual measure of the object. So I'm going to start by making note of that, and then I'm going to put 1,000 over 1. Now notice that this is a scale with no units. All that tells us is is that whatever our second ratio is, the units will be identical. So it doesn't matter what you start with, you're going to get the same unit afterwards. So it says you observe the width of a hair that appears to have a length of 12 millimeters. What is the actual length? So what we're looking at, even though it's not technically a drawing, it's a magnified view of the actual object. So we're going to think of it like a drawing, and we're going to put that up top. So it's 12 millimeters up top. And then in the denominator will be our unknown value of the actual measurement. So I'm going to make sure I note that it is millimeters. So for this one, I'm going to use cross products. So if I multiply diagonally, I will get 1,000x is equal to 12. And then I'll divide both sides by 1,000 in order to isolate x. And what I find is that my answer is just 12 thousandths, which you could express as a decimal. It would just be 0.012, and again, the unit is millimeters. On all of these problems, you must have a unit, so don't forget about it. Okay, the next one says, your family decides to put in an in-ground pool. The contractor uses a 1/4 inch scale. If the pool is 1 inch deep on the drawing, what is the actual depth of the pool? So if you recall back from the table, it reminded us that a 1/4 inch scale, typically used in contracting, is just simply to show you that every 1/4 inch on the drawing would be a foot of actual space. So I'm going to go ahead and make my scale 1/4 inch over 1 foot. So that's the drawing over top of the actual. And then I'm going to fill in what we know. So what we know right now is that on the drawing, the pool is 1 inch deep. So that's going to go up top. Another hint is that the unit matches with the numerator, so 1 inch up top. And we're trying to figure out the actual depth of the pool. So I'm going to put my unknown in the denominator. But I know the unit will be feet because it matches with the units of the scale. So a couple different ways you could do this. For this one, I'm going to figure out what multiplies by 1/4 to get to 1. And I know that it takes 4 quarters to get to 1 whole. So I would need to multiply by 4 in the numerator. And then whatever I do in the numerator, I must also do in the denominator. And that tells me that my answer would be a depth of 4 feet. So if you wanted to use cross multiplication, you absolutely could. That's not a problem, but this was just showing you with another method. Okay, let's look down below. Okay, so just a quick reminder to you, we also are looking today at scale factors. And so when we got to a scale in which the units are the same, that's really also known as a scale factor. So scales and scale factors are really one and the same, but specifically a scale factor is when we have the same unit. So if you are given a scale that doesn't have the same unit, you can actually convert it to a scale factor where the units are identical. So for example, we see in this scale 1 inch over 2 feet. So what I can do is try to convert those both so that they're still equivalent, but they have the same unit. So for example, I know that 2 feet is actually equal to 24 inches because I could think of it as multiplying by 12, right? So then if I get 1 inch over 24 inches, anytime I have the units on top and they're identical, it's almost like they're not even needed. And so that translates to a scale factor of 1/24. So if you are then given a scale factor, you can identify if the object is getting larger, if it's getting smaller, if it's staying the same. And the words that we learned for that is if it is greater than 1, it is an enlargement. So we'll just say greater than 1 is an enlargement. And that means it's getting bigger, of course. If it is less than 1, then it's a reduction, meaning it's reducing in size, it's getting smaller. And if it's equal to 1, which sometimes does happen, then we say that it preserves, meaning that the size of the object is not changing. So in this next example, we're asked to identify this. So it says, tell whether each scale reduces, enlarges, or preserves the size of the actual object. So let's start with 24 inches over 1 yard. And you really have a couple options for how you want to convert. It's whatever you choose. I just need to get the units to the same. What I notice in this one is that I know 24 inches can easily be converted into feet because it's equivalent to 2 feet. So I'm going to write that down. And then I look at 1 yard. And I also know that 1 yard is equivalent to 3 feet. So what I've just done is got them to the same units. Because the units are the same, they will cancel. And that tells us that our scale factor is 2/3. Now we're not finished. We have to identify if it reduces, enlarges, or preserves. So I look at this scale factor, it's 2/3, that is clearly less than 1. So the answer would be that it reduces. For the next one, we have 1 meter over 100 centimeters. If you have to look back at your conversion sheet, certainly you may do that. But what I find is that 100 centimeters is actually equivalent to 1 meter. And so now I write it like that. The units will cancel and I get a scale factor of 1 because 1 over 1 equals 1. And so what that tells me is that it preserves the size of the object. Okay, a few more that we're going to look at very quickly. The first one says, what scale factor relates a 24-inch scale model to an 8-foot tall truck? So if we're looking for the scale factor here based on this information, I'm going to take the model measure first over the actual measure of the truck, just like we've been doing consistently. So we'll set it up first as a scale based on the information that we know. And that would simply be 24 inches over 8 feet. Now, because I need to get those to the same unit, the easiest conversion would probably be to change them both to feet, which means we won't actually even have to change anything in the denominator. In the numerator, though, I know 24 inches is equivalent to 2 feet. So I would have 2 feet over 8 feet. The units would cancel, and I can simplify. So I'm going to divide by 2 in the numerator and denominator, and I will get 1/4. So the scale factor here is 1/4, and clearly the scale model is a reduction of the actual truck because it is smaller than 1. Then this next question says a model of a 48-foot tall building was made using the scale of 3 inches to 2 feet. What is the height of the model? So this goes back to proportions are a good way to solve this type of problem because we can just start with the scale, 3 inches over 2 feet. And we remember it's always model over actual or drawing over actual. So in this case, we are given the model measure. I'm sorry, it says the model of a 48-foot tall building, so we are given the actual measure. So we're going to put 48 feet down here. And this time we're going to be looking for the model measure. So now you notice there's a couple ways we could do this. I would say cross multiplication might be a good method to try in this instance. So we're going to go ahead and cross multiply. We would get 2x is equal to the product of 3 and 48, which is 144. Now to solve the one-step equation, I would divide by 2. And when I do that, I get an answer of x is equal to 72. Now you have to think back to what your units would be here. So because our scale up here was 3 inches over 2 feet, we knew the actual measure was 48 feet. Our unit would be inches. So the model of this building would be 72 inches tall. All right, thank you.